Okay, so continuing on here, looking at predicting the products of these precipitation reactions. We got one more example here, and again, we want sort of the same setup. We want to finish the molecular equation, we want to write and finish the total ionic equation, and then we want to identify the spectator ions and then figure out the net ionic equation for this reaction. So AgNO3, that's silver nitrate. Silver nitrate is going to be soluble. Again, nitrate salts are always soluble. So silver nitrate is going to split into silver cations, +1 charge, aqueous, and nitrate anions, -1 charge, also aqueous. The other reactant, potassium chloride, is soluble. Of course, potassium salts are always soluble. So that is going to break up into potassium cations and chloride anions. Okay, and from there, we can try to decide what is going to happen in this reaction. Now, silver was soluble with nitrates, because nitrates are always soluble. Silver won't interact with potassium because they're both cations, but silver now has the possibility of reacting with chloride. Well, silver doesn't have a rule, but chloride does. The rule for chloride was they're usually soluble, but 3 exceptions: silver, mercury, lead. Silver is one of the exceptions. So silver and chloride are going to join together, form a solid that's going to precipitate out of this solution. The way we write that in our balanced equation is to write out the formula for the ionic compound and call that a solid. So 1 silver, 1 chlorine, because +1, -1, we just need one of each to make the right formula for the product. Now, the remaining ions here, potassium and nitrate, both of those ions always are part of soluble compounds. Potassium salts are always soluble, nitrate salts are always soluble. So they will remain as spectator ions. So we still need their charge, but we're going to have AQ, or aqueous, as their phase indication. Silver chloride solid, that would appear just the same here in the molecular version of the equation. And we can complete the molecular version of the equation by making the correct salt between potassium and nitrate. So that would be KNO3, one of each, and we need to indicate that that is aqueous. It's still dissolved. Right? Nitrate and potassium were soluble on both sides, so they are the spectator ions. They will not appear in the net ionic equation. The net ionic equation here is silver, soluble silver, reacting with soluble chloride ions to form the silver chloride solid. Okay, now, like I mentioned before, that's going to be on the test. One of these reactions or something similar. You want to be able to do all these pieces, all your charges, all your phases, everything right. You really need to practice these. Right? We will be doing some exercises and we'll be doing some laboratory work to help you get a handle on how to do this. Right? But make sure, right, kind of like the polyatomic ions, you've got to put in a little time on practicing applying your solubility rules and working out these equations. Right? And these are not the only equations that we are going to be dealing with in this particular chapter. There are some other reactions that we also want to be able to kind of balance and predict the products of. Right? And we've got 3 different types of reactions, all have to do with acids. So acid is a particular type of chemical. And the way we can generally recognize an acid in terms of formula is the formula is going to start with H, or hydrogen. So to be an acid, compound has to have a hydrogen that it can donate as a cation, as H+. So when we look at a chemical formula, if you see H in the first spot in the formula, that makes it an acid. So something like HNO3, that's an acid, that's nitric acid. But if you see the hydrogens in another position, excuse me, like in methane, CH4, the hydrogens are not at the front because methane is not going to behave as an acid. Okay, so when we look at a reaction, the first thing you may have to decide is, am I looking at a precipitation reaction like we just talked about, or am I looking at one of these acid reactions? Right? If you find an acid, you're looking at one of these acid reactions. Now you may still have to consider solubility rules, but you basically need to kind of recognize what equation you're looking at. So the first reaction we want to talk about here with acids is what happens when an acid reacts with a metal. So in this case we've got magnesium, that of course would be our metal, reacting with HCl, that's hydrochloric acid, that is our acid. Two products with this type of reaction. When a metal reacts with an acid, you form a salt, right? And the salt is going to be the cation of the metal and then the leftover anion from the acid and hydrogen gas. Okay, and that is something you will need to know, because on a test it'll look more like this. I'll just give you a metal, I'll just give you an acid. You'll have to figure out what ends up on the other side and then balance the equation. Okay, and I've got several examples of each of these reactions, but again, this is something you'll need to practice so you can recognize what you're supposed to do. Am I looking at a potential solubility reaction where I need to figure out what the solid is, or am I looking at acid reacting with something and then I need to apply what I know about the different types of acid reactions? So let's look at this example. So zinc here would be our metal. HCl again is our acid. This is hydrochloric acid. Now following the example up above, one of my products is going to be hydrogen. It doesn't matter what order you put the products in, but H2 gas is going to be one product. The other product is going to be the salt. Now, zinc can make a salt with chloride, since zinc always has a +2 charge when it's in an ionic compound. That product would be ZnCl2, right? And that's a chloride salt and not one of the exceptions, so that would be aqueous as a product. Now, from there, I want to balance the equation, right? There's just one zinc on each side, but 2 hydrogens and 2 chlorides on the product side. So to balance the equation, I would need a 2 right there, okay? So that's the kind of thing you're going to be expected to be able to do when we do get to an exam. And again, there's some of that chapter 2 ionic formula information in here as well. You've got to get your salt right. If you don't get the formula of the salt right, doesn't matter what you do with balancing the equation, because the equation is wrong. So you have to know how to make the right salt based on, you know, what metal am I looking at? What charge is it going to have? How many of the anions are going to attach? What's the charge of the anion even? Because there's multiple different acids that we could use. Okay, let's go into the next section. I think we can fit that comfortably into this, video. So acids and carbonates. What happens when an acid reacts with a carbonate? So here's our reaction. HCl here is our acid, and we have sodium carbonate, Na2CO3, that's our carbonate. Right? Acids and carbonates are always going to react to produce 3 products. Those are going to be carbon dioxide, that is a gas, so it better be labeled as such in your reaction. Water, right? And water is a liquid. Notice the L there in the products. And again, a salt. Now, this salt is going to be the cation left over from the carbonate, or a hydrogen carbonate is also a carbonate. So the sodium left over from the carbonate and the anion left over from the acid. So the acid is donating the hydrogen here. There's going to be chloride left over. So sodium chloride is left over from the acid. So let's do one of these, and that'll wrap this particular video. Okay, HCl is our acid. Sodium hydrogen carbonate here as well. So a hydrogen carbonate qualifies as a carbonate as well. This is going to give us that same set of products. Always CO2, always water, right? And then always a salt. Now the salt in this case is also going to be NaCl. Sodium left over from our carbonate, chloride left over from our acid. And sodium chloride we know is aqueous, so we'd want to put aqueous on there. Now from here we need to balance this equation. So if we just look at hydrogen first. We're getting one from the acid here. And there's also one that comes from the hydrogen carbonate. So there's the two hydrogens that form the water. So that is okay. One chloride here, one chloride there, also okay. One sodium, that's good. The carbonate, the carbon and two of the oxygens end up in the CO2. The other oxygen ends up here in the water. This particular equation is actually balanced with just one for all of the components. So in this case, you just need to identify the correct products. You wouldn't need to balance it. Not always going to be the case, and we'll see that in the next example, but that will be in the next video.